working. Alright. There's an interesting pattern of numbers that makes up what's referred to as Pascal Triangle. So you got that, right? You got that as Pascal Triangle. And first 6 rows are shown. 0 is the first row, 1, n equals 1 is the second row, and so on. Starting point is n of 0. Okay? So, first of all, for 1a, describe all the patterns that you see in Pascal's triangle. Should be pretty easy because Ted told you some of them. So, just looking, talk with your partner. That's a part of it. Talk with your partners, all the patterns that you see in Pascal's triangle. Alright, so what are some patterns that you see in the triangle? No one knows. A hush falls over the classroom. Alright, yeah, it's ones on the end. On either side, there are ones. Okay? What do you notice next? I heard some stuff. I was walking around. I had to talk. What else did you see? One else? Yes.
Like you take all the outside. So you go 1 and 4. You go from the bottom. So 1 plus 4 is 5. 1 plus 3 is 4. 1 plus 2 is 3. 1 plus 1 is 2.
Okay, so like if I add these two, I get that one?
Yes, sir.
And if I add these two, like that? Yeah, that's right. If I add those up, even those, like any two numbers you add up, you get them. Okay, good. Yes, very good. Very good. Anything else you notice? Yeah, if you go like right here, you could fold it. It's exactly the same on either side. Yeah. Anything else? Somebody said this. And this. What do you notice right there? What do you notice? 1, 2, 3, 4, 5. Yeah, that one goes. Okay, so make the next 2 rows. Do n equals 6 and n equals 7. Write in the next 2 rows. Very obviously pattern. Brady pointed out exactly how you can find the next 2 rows. So find the next 2 rows. Alright, so what's going to go here? 1, and then what will go here? Here? Okay, the next row, what about here? You add the previous 2 to get that 1. Okay. Very good. Alright, let's look at Brianna and her hockey, her love of hockey. So this says Brianna loves hockey. In fact, Brianna is so obsessed with hockey that she drew Hockey sticks around numbers in Pascal's triangle. Lo and behold, she found a pattern. Can you see the pattern that she found inside the hockey sticks? Brady sees it. Anybody else see it? Yeah? What's the pattern? Right. If you add up, I don't know anything about hockey sticks. You add up the handle part, I guess. I don't know. It equals the part that actually hits the puck, right? Is that right? Is that, I mean, yeah? Okay. Alright, so let's make 2 more hockey sticks. Let's try to go the other way. If I did this, is it still true? If I do this, is it still true? It looks like a golf club. It looks like a cast on a foot. That's what it looks like. Yeah. Alright, let's talk about Drew and Latasha. Alright, Drew and Latasha analyzed Pascal's triangle and each described a pattern. Drew said the sum of the numbers in each row is equal to 2n, or 2 to the n, excuse me, where n equals 0 represents the first row. And Latasha said, if I alternate the signs of the numbers in any row after the first row, and then add them together, their sum is 0. Who's correct? Either verify or disprove each student's work. Alright, so look at Latasha's and Drew's work and see, they could both be right, they could both be wrong, or it could be one or the other. So figure it out. Okay, what is Drew saying? What does he mean? For 2 to the n. 2 to the 0 would equal what? Okay, and 2 squared would equal what? Sorry, I skipped a number. 2 to the first would equal 2. 2 squared would be 4. 2 to the third would be 8. 2 to the fourth would be 16. Okay, so he's saying that the sum of the numbers in each row is equal to 2 to the n. Well, let's go back to the triangle. Well, we can use that one. First row, what's the sum? What's the sum of the second row? What's the sum of the third row? What's the sum of the fourth row? No. Yeah, fourth row. 8. So is Drew right? Yeah, Drew's good. Okay, and then what does Latasha say? If I alternate the signs in any row after the first row, then add them together. Okay, so we're going to start with a negative and add them together. Okay, but not the first row, because the first row only has one thing. So that's a negative. Does that equal 0? Okay, negative, positive, negative. Does that equal 0? Boom, boom. Boom, boom. Alright. Alright, so yep. I'm gonna say they're both right. Yeah. Both of them are correct. Yes, you can skip her up. Alright, let me erase this. Okay, now let's get down to the patterns in Pascal's triangle have many uses. For instance, you may have used Pascal's triangle to calculate probabilities. Probably not. Let's explore another use of Pascal's triangle when raising a binomial to a positive integer. going to multiply these out. Okay? Anything to the 0 power is what? 1. And a plus b to the 1 power, anything to the 1 power is just itself. Okay? A plus b. And then if we square it, it's going to be a squared. Plus 2ab plus b squared. Now, cubing it, that's going to take a minute. To cube it, this, what we just got on this one, has to be multiplied times a plus b. So let me go over to the side here. What's a squared times a? Alright. What's a squared times b? How about 2ab times a? And 2ab times b? What's b squared times a? How about a b squared? Let's just put it that way. And b squared times b? B cubed. Okay, so that's going to be a cubed. Almost done. How many a squared b's do we have? 3? No, that's not it. Plus 3ab squared plus b cubed. Now for ab to the 4th, yeah, this has to be multiplied times ab. I think I need a bigger space. So it's a to the 3rd plus 3a squared b plus 3ab squared plus b cubed. Is that right? And then I'm multiplying that times ab. I think it will be easier if I go this way. So that's going to be a to the 4th plus 3a cubed b plus 3a squared b squared plus a b cubed plus a cubed b plus 3a squared b squared plus 3ab cubed plus b to the 4th. Alright, like terms. I have an a to the 4th. Anything go with that? 3, 8, yep, right there. Here and here. 4a cubed b 6a squared b squared 4ab cubed plus b to the 4th. Alright, compare the coefficients with me. Pascal's triangle. Okay, did you write this in your book? I'm moving it. I'm going back to the book. Got it? you have it? Plus 6. So compare this with the coefficients in Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Oops, put that over there. 1, 4, 6, 4, 1. Pascal's triangle, right? What about the powers? What about these? Anybody see a pattern with those?
I do.
What do you notice about the exponents? And what do you notice about the exponents and the A term? Okay, they sort of mirror each other. Like here it's 1, and there it doesn't exist. Okay, it's not there. It's 0, basically. 2, 1, 0. 3, 2, 1, 0. 4, 3, 2, 1, 0. And what happens with the B term? 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. So you can use Pascal's triangle to not have to do all that math that we were just doing.
It's like a multi-purpose tool.
It is, yeah, it really is. Let's see, on number 7 on page 390, I think it's your 390 also. I think it's supposed to matter. It talks about, alright, use Pascal's triangle. So if I want to do a plus b to the 5th, okay, a plus b to the 5th, I'm going to look at Pascal's triangle, and I'm going to go where n equals 5. Okay? You can go back to page 386 and see where n equals 5. Because I'm doing a plus b to the 5th, so n equals 5. So my coefficients are going to be 1, then what? 5, 10, and 1, okay? Those are my coefficients. My highest power, it's to the 5th, so it's going to be 5, right? So here, A is going to be to the 5th power, and B is going to be to 0 power. But what happens here? Right? And then what happens here? And what happens here? A drops 1, B adds 1, so it's going to be A to the 1st power and B to the 4th plus B to the 5th. Without all that multiplication. What don't you get? What don't you get?
How to do that?
Okay, what's that? Which part is that? Okay, did you go to Pascal's triangle and look at n equals 5? And did you see where it's 1, 5, 10, 10, 5, 1? Alright, those are our coefficients. So we just copied those down. Alright, and then the pattern for the variables is that A starts at whatever number you are on. We are on 5, so A starts at 5 and then drops by 1 every time. B starts at 0 and adds 1 every time. So A to the 5th, 4th, 3rd, squared, 1, and then it's not there because it's 0. B is 0 right here, so we didn't write it. 1, 2, 3, 4, 5. It's just following the pattern. Just applying the pattern. That's all. Okay? So what about 6? What are the coefficients for row 6? I know it's 1, then what? 1 and then what?
Oh.
Not yet. I want the coefficient. 6. Okay. So this is going to be a to the 6 plus, what's this one going to be? And then b. Okay, and this one? Yep. How are we getting the a values? Going down 1. How are we getting the b values? Okay, so this is going to be a, what? Second, b, 4. This is going to be a, just a, b, 5th, and this is going to be, yes. Isn't that much easier than multiplying it out? Yeah. Even if you had to generate Pascal's triangle, like let's say you didn't have it on page 386 to look at, and you had to generate it, I think you could probably generate Pascal's triangle faster than you could do that multiplication, right? Yeah, I really kind of think you could. All right. Okay, now we're going to talk about binomial theorem, and it tells you to remember something, except I don't think that you were ever shown this in Algebra 1. So when it says remember, you have nothing to remember. So we're going to have to go back over what that means, first of all. Yeah, remember? No, I don't.
I remember the wire.
Yeah, we're recording right now. You just didn't have time to get to it, that's all. You don't have time. Alright, what if you wanted to expand a binomial such as a plus b to the 15th? You could take the time to draw, 15 rows of Pascal's triangles, but there's much more efficient way. Alright, recall that a factorial of a whole number n, represented as n exclamation point, is the product of all the numbers from 1 to n. Okay, so what that is saying is that, see this, have you ever noticed the exclamation point on your calculator? You're like, what the heck? Am I sending a text I really need to, put some feeling into? No, that is this factorial. And what this means is every number times itself. So it's 5 times 4 times 3 times 2 times 1. That's what that means. Okay, that's what 5 factorial means. Basically, let's see, 120. Okay? It's 20 times 6. How can you not do that in your head? Come on. Alright, this one right here, 2 factorial, 3 factorial, that's 2 times 1 times 3 times 2 times 1. That's an easy one. What is it? Yes. Okay. Now this one looks really bad, but it's not when you're dividing. Okay? Because when you have 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, what happens to these? Yeah, they're gone. These down here are gone, so 5 factorial over 3 factorial is 20. Exactly. Okay, so they're really easy, right? Factorials are easy. They're not bad. Yep. We're gonna look at one other thing, the combinations on the bottom. Did you ever have this written down? Because I gotta move the page. Not yet? Okay. Alright, you may have seen the notation N over K like this, or N, this capital C, and then a K. You may have seen that before when doing probabilities. Both of these represent a formula for a combination. Not a combination like on your log, but like I have 20 people in the class and I'm going to pick like 5 of them randomly. That's a combination or a permutation. Okay. For a combination, order does not matter, which is funny to me because if you've ever had a locker combination, order is really a big deal. Like if you don't put it in the right way, you don't get your locker open. So, but in math, combination, order does not matter, right? So they're going to show you on the next page, in case you've forgotten, they're going to show you on the next page how to do a combination. Alright, so what this means is that we have 4 things and we're pulling out 2 of them, and it doesn't matter what order. It's not like this is first place and second place. I just need 2 volunteers. That's what that means, okay? So this is how you set up the formula. The N is the 4, that's the number that I have, and the K is the 2, that's how many I'm taking. Okay? And basically you have 4 factorial over 2 factorial times 4 minus 2. Some of them cancel out, and you just have to, it's really easy, okay? It's really easy. Now, why does N have to be a greater number than K for this to work? Right? And if I'm choosing, can I take, they have to be whole numbers, right? It's can I get 8 out of a group of 4? No, it's not. So, yeah. Okay. So let's just try this. Okay? What's N, and with 5 over 1, right here, what's N and what's K? Alright, so it's N exclamation. So it's 5 factorial over 1 factorial. Bless you. Five minus 1 is 4. What happens to those 4 through 2, 1? Cancel. Your answer is just 5. 5 combinations. If I have a group of 5 and I'm taking 1 person out, there's 5 ways to do that. That's what that's saying. What if I have a group of 7 and I'm taking 4 people out? How many different ways could I do that? Well, that's going to be 7 over 4. Let's finish that one.